All right. So this is going to be the web crawling and scraping in R tutorial. So just to kind of introduce what these two topics even are, a lot of times economists or other sorts of academics need to have data from different data sources, and oftentimes they don't come in like downloadable formats. So sometimes you can find data that's not necessarily available on websites like Kaggle or something like this, but a lot of times you'll have to kind of create the data set yourself. Now, anything you can scrape, you can pretty much go through by hand and collect manually. So you kind of copy and paste into an Excel sheet or a text file or some other way to kind of collect your data. And you can do this. And this is, not so hard. Even if you wanted to export data from a website like the CDC, which we'll do, I'll show you how to like automate that with web scraping code. So there's a lot of ways you can do it without web scraping, but it just makes your life that much easier. It's a really attractive skill on the job market, of course, and it makes your life way more efficient. Plus that, I find it to be very enjoyable and fun. So the way I've kind of prepared this is there's a big markdown file that you can scroll through and read kind of my comments, but I'm going to kind of walk you guys through it. We'll do a little bit of coding at the same time in R. So I have RStudio pulled up. You guys had Zach Pareka, I think for the introduction stuff. He's great. Hopefully he went through some text stuff. I think Brian probably went over some text stuff too. For loops, things like this. So if there's any point in which Zach didn't get to something or Brian didn't get something, please stop me and I'll kind of go over what it is. But I don't think anything is necessarily too advanced here, given what you've already seen. And again, I'm not expecting you guys to like see this once and master it. It takes a lot of time, a lot of practice, but over time and with a lot of practice, you will be able to scrape whatever data that you may need for your dissertation or any project in the future. So before we kind of get started, we're going to talk about a R library called Magritter. So essentially, what this does is it allows you to use this little operator here, which is a %, a little caret, and then another %. Its technical name is a pipe. And essentially what it does here is you can see if you have a bunch of nested functions, like for example, I guess I can just copy and paste this into R and we can check it out. So essentially what I'm going to do here is I'm going to create 100 random numbers. I'm going to take the average of those random numbers. I'm going to feed it into an exponential function. I'm going to take the square root of that function, and then I'm going to print that. So notice how it's like a bunch of nested functions, one after the other. This is really not really readable once you have a bunch of these, but we can get an answer here. We get about 0.95. We can also do it with the Magritter package. So this is mostly cosmetic, but you can kind of think of this as like a waterfall. So the way that this works is you take your original vector, this x vector, and you want to put it into the main function first. So you can think of it as it takes this and it drops it into the argument of the mean function, and then takes the result of this line and puts it into this line, and then so forth. So it's kind of like reading the code backwards, whereas here I read it as print square root exponential mean. This one is more like a step-by-step. It's a little bit easier to read. Plus what you can do here is you can write comments. So like, taking the mean of X. So it's easier to comment your code. It's just a much cleaner way to look at stuff. R now actually has, if you have the newest version of R, they have a native pipe. I think it looks something like this. But I learned Magritter before this native pipe was available, so I'm just going to stick with Magritter. I like it. So one important thing is that Magritter will put whatever you're piping, it will put it into the first argument of the function. So this is a decent illustration. If I put in 5 into rnorm, that's saying the first argument of rnorm is n. So that's just like the number of random numbers you want. And there's a default mean and a default standard deviation. So piping 5 into rnorm is just going to create 5 random numbers with a mean of 0 and a standard deviation of 1. Now, I can put it into the second argument, which would be the mean argument. And, I can specify actually what I want n to be. So for example, I can do 4 comma period, and that's going to put this 5 into this little placeholder, which is a period. So you can see the output here. There's going to be 4 numbers with an average of 5, standard deviation of 1. Similarly, I can put into the third argument and so on. You can even go as far as putting into all 3 arguments with 3 placeholders. But the default is always the first argument. Okay. Are there any questions about Magritter? That's just a little bit of a kind of package just to kind of get us going. We're going to be using it a lot in this tutorial.
What was the set seed line for?
I'm not sure if I can hear Darby. I think you're speaking. I'm not sure if I can hear you.
I can always type it in the chat if you can't hear me. I was asking what the set seed line does.
I might be having sound issues.
She was asking if.
Yeah, I can't hear anybody. Hang on.
Oh, okay.
Let me see. Speakers. Okay, so the question is, what does the set seed line do? I'm gonna try to fix my speakers for quick. Okay, can you guys try asking a question again? Sorry.
Hello?
Oh, the set seed line?
Okay, cool. So my speakers work now. Hopefully there's not too much of an echo, but so be it. So the set seed line, all that's doing, and this is something if you're a macroeconomist or even just somebody who's doing simulations, this is a really important thing. Set seed is essentially setting the randomness. So for example, if I set the seed to 6, 7, 8, just a random number I just picked, it will do it such that every time I do rnorm 100, the same 100 numbers will come out. So it's important when you're doing simulations that you set the seed, because for example, if you are writing a paper and you simulate some t-statistic as like 2.5, but you don't set the seed, and then you go to redo it like an hour later or even a second later, it's going to be a different outcome for the random number generation. So setting seed is just a way to make sure that everyone's kind of getting the same random numbers, if that makes sense. So they're random insofar that there's no pattern to them, but it's kind of setting an anchor is the way I think of it. Hopefully that answers the question. Okay, cool. So now that we've kind of gone through Magritter, is there any other questions about Magritter? Yeah, so Josie says in the comments that it makes your code replicable. Yes, that's indeed the case. Okay, so now that we've covered that, again, just mostly a cosmetic piece, we'll talk about HTML. HTML is the predominant language that websites are built in. And essentially, this is a pretty good snippet of what like a really, really basic HTML document might look like. You can think of it a lot like a data frame, where you have these different elements, and within those elements, you have other elements. So for example, a data set, you'll have state by year GDP. And then within that, you'll have like separate states. Within those separate states, you'll have separate years, right? So each of these things is going to be denoted by some sort of node. So this is the main HTML node. You can think of this as like the main document. And then this HTML node has 2 subnodes. It's head and body. Head only has 1, again, subnode, or child, I think is usually the word people use. Same thing with body. There's 2. There's an H1, which is like a header. And then P, which usually stands for paragraph. You just write out this, this is a paragraph. So if you were to build this, it'd be a super simple website, but that's kind of the structure in which it's looking. You can also think of it as like a file structure. Like you have your Dropbox. Your Dropbox has different folders for different projects, and within each folder, there's data, there's code, there's literature, stuff like this, and then you kind of keep building out that way. So in order to access these things, you kind of have to tell the computer, I want HTML head title or something like this, if that's what you're after.
Hey, Alex.
Yeah.
will it automatically enter the spaces, or do you have to enter those? Because I know some of this gets tricky with space.
Yeah, so this is just like a random HTML example. So we're not actually going to be typing any of this stuff. This is just like what it would look like. And
Right, I'm saying like how there's space, like, so say after HTML, in line 4, it's like indented. That's what I'm talking about. Like, are you tabbing? Are you, or is it?
Yeah, so HTML, I don't think it matters tabbing for HTML. Like I think like the spacing doesn't matter for R, but like Python, it's
Right.
all based on spaces.
Right, yeah, that's what I'm used to. That's what I was asking. Okay, thanks.
That's a good question. I don't think HTML matters, but we're not writing HTML at all, so I wouldn't even worry about the intricacies of like spacing and stuff. We're just looking at ID names and node paths. So kind of going off of this, none of these tags have identifiers. You can write this as like head and then space ID equals like my header or something like this. And then you can reference that node by just putting into the computer or the code that we're going to write like hashtag my header, and it will go right to that because IDs have to be unique generally. But these ones don't. So in order to access the head, you would have to do like HTML caret head. So for example, if we're looking to get some of these, like one of these here. So if you wanted the H1, it would have to be like body caret H1. So this is how you would access when you're ends up scraping stuff. You'll have to put in the actual file path or the node path. But again, if there's a name, if it's like if it's ID'd, then you'll have like per game stats. So we're going to scrape basketball reference for some basketball data, and we'll have some nodes that look like this. But then there are also going to be nodes that could look, I mean, absolutely insane, like these ones. This really has no meaning to me other than this is some identifier, goes to some div with a class of SJCL. Here's another div, right? So these are just kind of like flexible node paths. So they can be kind of crazy, but it's not so hard to get them. Oftentimes you just need to copy and paste from the website. So I'm promising to teach you guys both crawling and scraping. So these are two different things, even though they're kind of used interchangeably generally, but they are different. So usually the steps are you crawl first and then you scrape after. And the whole point of this is crawling is when you access a website and you save what you see as a separate HTML file locally onto your computer. This could be for a variety of reasons. For one, if you are scraping 10,000 websites, web pages, you don't want to have to, if you forget to grab something from one of the pages when you're scraping, you don't want to have to go re-crawl those pages all over again. So rather you would just crawl the pages, save them, and then scrape them later. Another reason for this would be if a website doesn't keep the same information. So for example, if you're looking at some sort of daily update of numbers, some sort of statistics that come out every day, maybe you want to scrape or crawl every single day so you can have a time series of these data where it wouldn't necessarily be available if you were to look, try to get historic data at this point. So there's a bunch of different benefits to crawling. Sometimes it's pretty easy. You can kind of skip that part, but oftentimes you'd want to be able to kind of save what you're going to scrape so you can go back to get, more stuff later or something like this. So every website most websites are crawled by websites like Google. So what Google will do is it's just crawling. It will go find some website, for example, basketball reference, and it'll start indexing the pages. So just following links, things like this, and just kind of making a web of all of these nodes. And then when you search for things like, Knicks roster basketball reference, it can kind of pull that out, and then you can access that page through Google. That's essentially what they're doing, but at a much, much higher level, of course. But therefore, each of these pages needs to be able to communicate both with Google as well as people like us, amateurs, right? So for example, a lot of these websites will have a web page called a robots.txt, and that'll essentially tell the user what they're allowed to crawl, what they're not allowed to crawl, sometimes they ask for a crawl delay, which is, they don't want you to overload their servers with a million requests in a second. So they want you to wait 3 seconds, or they want you to wait half a second between each of your requests when you're programming it so you don't overrun their servers. So for example, here's one from Basketball Reference, a website we're going to be crawling later. So the way to read these is it'll specify the user agent. So hrefs bot, they're disallowing them from everything. So maybe these people were, abusing their privileges, and they really don't want these people to crawl them anymore. User agent star means everybody. So essentially what they're saying is we really don't want people to scrape things that have /blazers/ in the URL. Can you scrape them? Of course, but they don't want you to. So that's kind of one way to get blocked on websites. Happens plenty of times, probably not frequently, but it does happen. So I always try to make sure to check their robots.txt. Another example here is they want your crawl delay to be 3 seconds between each call. I'm going to ignore that in this tutorial just because we're just going to be doing some quick stuff, so it's not a big deal. But generally, if you're making a massive request, a massive web scraper, you're going to want to respect their preferences. Here's some other ones. Here's one from the CDC. So even government websites kind of have these sorts of things. And then here's kind of a cool one from Nike.com. They have a cool little swoosh here that looks kind of neat. So there's a bunch of different cool things you can find on robots.txt pages. Okay, but now we're interested in scraping a web page. It's going to be the Knicks 2019 roster. So this is the web page that we're going to try to scrape, or crawl rather, and we're going to scrape it after. So here's just the roster. Here's all the players, their positions, their heights, their weights, their birthdays, their nationality, their experience in the league, right? So maybe I want to get this data for some research project I'm working on. So the first thing we're going to do is we're going to set up our script. We're going to grab some of these libraries. So XML2, we're going to use, this is going to allow us to write out our HTML. So once we ingest it through R, we're going to be able to write it to a local file. That's what XML2 is going to do. RVS is going to do like 99% of the heavy lifting for us. This is like a pun on harvest, but this is pretty much the web scraping package in R. It was just updated just recently. It's fantastic. It's really, really good. Here's Magritter. We had just talked about this one. And then we have one more called JSON Lite. JSON is a way of displaying data that a lot more places are kind of moving to. I saw somewhere, I'm not sure how legitimate it was, but there was something with government websites where they're trying to move every government API and things like this to a JSON format. It's kind of the way the world is moving. It's a little bit more flexible than, like, for example, a CSV format. So we're going to do some JSON. We're going to look at some JSON files as well. I'm going to set my folder to something I have locally on my desktop. So this is just the Empirical Workshop 2020 scraped HTML. This is where we're going to store everything. I'm going to set my working directory. So now it's there. And we can look at what files I have in there right now. I have nothing. It's a completely empty folder. And I'm going to open it up as well. Desktop. All right. So this is the scrape HTML. It's completely empty. So in order to crawl this page, it's going to be super easy. What we're going to do is we're going to save the link that we want, right? That link is going to be this one right here. So this is going to have the information that we're interested in. We're going to feed that link into read HTML. If I just run this page, this line right here, you'll see it comes back with a head and a body. This should be ringing some bells from before when we looked at a basic HTML page. Most of them are built like this, where you have HTML and then you have head and body. And then all we're going to do is we're going to save that as my HTML. So now my HTML is over here. It's a list of 2. that list is going to be, the first element is going to be head. And of course, within there, there's going to be a bunch of sub elements, sub nodes. Same thing with body. So we're just crawling. We're not scraping. We're not trying to get any of the information off the page yet. All we're trying to do is crawl this. So what we want to do is we want to load the page into R, get all the HTML information, and then we just want to write it out into a local file. So once we do this, we should check our folder again. We have Nix 2019. So now I've taken the HTML off of the internet and saved it locally onto the website, into this folder. We can also open it up, see what it looks like. And here's the internet version. You can see basketballreference.com/team/New York Knicks/2019. This one says C users Alex C desktop empirical workshop, right? So it looks almost exactly the same. Sometimes it'll look a little bit different just because it's not connected to anything. So sometimes there are websites that need to pull information or have other fancy scripts associated with it. This one is super basic. So it comes up pretty much completely done for you. So that's it. That's all it is to scrape or to crawl a really simple basic website. And it was just like 5 lines of code. So really pretty easy for this right here. Before I move on, is there any questions? Okay. So that's the how to crawl one page. Great. However, what if we have multiple pages, right? What if we want to track the Knicks roster over time? So luckily, there's little buttons here that say previous and next season. And for example, this is the 2019 season. If we use if you use the previous season button, you can see in the bottom left of the screen, it should say, I don't want to move the mouse here because it'll take it away. But right above like the Windows icon, it says HTTPS : and then Knicks 2018. So when we click on this button, it's going to change the URL to 2018. So we know how to scrape that too. We can do the same exact code. We can just kind of put it there. But instead, we're going to write something called a for loop, which hopefully you guys went over. Can you guys give me a thumbs up if you had gone over for loops before?
Yes.
Okay, cool. So we're going to write a quick for loop. We're going to scrape the 2010 to 2019 Knicks roster. So we're just going to steal this code right here. So instead of 2019, we want a more flexible piece of code here. So this paste 0, and then if we put I, this is going to change the link through the first one. When I is equal to 2010, it's going to scrape the 2010 roster, and then so forth. So we're going to have this go, and if we were to run this, it would keep getting, it would keep overwriting the same file. So we're going to also edit this. And put an I there. And now if we were to run this, it'll take a second. But now when we go to our page here, we have 10 rosters. You can see all the sizes are different. So presumably all the data is different. And now you've scraped multiple pages, right? So just using a for loop is usually the easiest way to go through and scrape multiple pages. So a lot of times, sometimes data is really easy to, or pages are really easy to scrape. The data is on the page, you scrape it or you crawl it, whatever, save it, and then you're done. And then you can, extract that data later. But sometimes it's not that easy. So here's an example of one that's maybe not so easy. So this website tells the number of people who are on the government website or any government website at this point in time. It'll break it down over different devices, different countries, things like this. But if we wanted to scrape this number or crawl this number, maybe we want to do it once an hour or once every day, and we want to get a time series, and maybe the government doesn't save this data, so we want to do it, and we want to do some sort of time series analysis on it. Well, what we could do is we could scrape this number. So what we would do is we would do it the same exact way. where we read the HTML and then we save that HTML. But just to kind of give a little bit of a sneak peek into scraping, we're going to access the node current visitors, and we're going to print that text. And that's just going to give us 3 dots. And if you look really closely, if you watch this number as I refresh the page, you're going to initially see 3 dots. So I'll refresh it. Maybe not this time. So you can, hopefully you saw it that time. Really, really quickly, there's 3 dots. And what's happening is the website loads as a skeleton. And then there are other scripts in the background that are loading the data from other APIs and then filling in the data on the web page. So essentially, when you go to scrape this, or when you go to crawl this, it's crawling the initial HTML. So not when it's filled in with all the data that gets pulled in. So you're going to be missing some data that might get filled in via an API of some sort. So that's no good. So in order to do this, what we're going to do is we're going to, on Google Chrome at least, we're going to hit Control-Shift-I. I've got a PC, so Control-Shift-I will work. And usually it'll look something like this. This is all the HTML on the website. And we can kind of click through this, for example. So this is the body. You can see this is some container, and there's a bunch of data here, stuff like this. So this is kind of what the HTML looks like. But what we're going to be interested in is this network tab. So network, this is going to be stuff that's being pulled, especially when it says XHR. These are results of API calls. So for example, if I look at this right here, this says realtime.json. If we look at what this looks like, a little preview, we have the number of active visitors, 8,584. Notice that matches this number right here. We have some other information here, some query stuff, whatever. But essentially, we want to scrape or crawl not this page, but this page. So if we right click on it, we can open this in a new tab, and we'll have the data here. So we have active visitors, 8,584. So what we're going to want to do instead is we're going to want to crawl this page over and over and over again. So when you set up your daily scraper or your hourly robot to kind of go through this, you're going to want to use this page instead. So a lot of times you'll have to check to see if this is updated dynamically or if it's just a static website like Basketball Reference. So in this case, we're unable to find this data because it's just ... But once we look through the XHR files, we can see that, hey, they're actually using an API and it looks like this. And then once we access that data, we'll get the data that was there before. So this, I had built this this form earlier, so the numbers aren't going to match, but the idea is the same. Are there any questions about that one? Okay, so again, we're still not even really grabbing data off of a page. We're still just learning how to crawl it, how to see the data that we want and save it and store it. So another thing to do is maybe you have some data set that you're interested in. Let me X out some of these. Like CDC Wonder. CDC Wonder is a really cool database. I'll just start over here, just plugging the CDC stuff here. There's all sorts of different databases you can access. So for example, we're going to look at daily fine particulate matter. So if we click on this, there's this little form that you can fill out that you can export data however you want. So for example, we can also organize it however we want, so like this. And then once we're done, we can send the request and it will download the data from the CDC Wonder page for us, usually the text file or something like this. That's cool, but maybe you have a ton of different requests to make. Maybe you have, a really large request, and the CDC, I think they tap out after like 75,000 observations. So if you're trying to do a bunch of different ones, it might just be, not good enough. Or maybe you just want to be able to document and replicate what you're doing. A lot of times it's tough when you're trying to remember like how you got data in from a certain way, or if you manipulated data in Excel. That's obviously a strength of coding, that you can replicate these steps. So this would be a way to be able to replicate getting data from the CDC. So what we're going to do is I'm going to kind of walk you guys through how to submit a form. A form is pretty much filling out all this information and then hitting that send button. So let's suppose we want to get data from or for a certain number of FIPS codes. So these are counties. So here are a couple counties in New York, a couple counties in Virginia, and a couple counties in Pennsylvania. So I'm going to copy these. I'm going to put these in R so we can see it in real time. So when we run this, we'll have our FIPS codes. Here are our FIPS codes. And then we'll also have our state codes, just because this is something that we need to use to plug into our into the CDC website. So here's me just kind of printing them. So we're gonna submit requests by state. For whatever reason, the CDC is like weird about grabbing Virginia and New York at the same time for whatever reason. So here's what we're going to do. We're going to take the URL that we're interested in, right? So this one right here, and we're going to save that as URL. And instead of doing read HTML, we're going to start a session. So when we start a session, I can print this. This is essentially like a robot driving a car. So we are kind of driving the car remotely through this HTML session. So right now, this session, I called it sesh, is connected to this website, and we're kind of give it directions now. So the first thing we're going to do is we're going to ask it for all the forms on the page. So when we save that, we have unfilled. If we look at unfilled, it's a pretty long list. It's got the first element is this formed right here. And this is a CDC search query box. So we can see if we can find that on here. So that form is referring to this search box right here. And then this second one is the wonder form. And this is going to be a post request to this database 73. Database 73 is the one that we're on. You can see here, find particulate matter. And it's got all of this information. So it's got these B's that we care about. It's got M's, got all these sorts of things. And what we're going to have to do is we're going to have to figure out which one of these are important. This is a pretty extreme example of a form. Most of them look much more like this, but this one looks as crazy as it does because it's got as many options as it does. So what we're going to do usually is I just take the unfilled form and we can kind of see what it looks like, what's there with it. That's kind of like the default. And then we're going to try to fill things in. So for example, these by results right here. So if I do inspect, one second. So if I hit send, it's going to send our data request. So it's going to send our form. And if we look at the headers, or the payload rather, it's going to look like exactly the form that we saw in R. However, the difference here is that B_1 is set to this thing, d73.v1-level1. What this is referring to is it's referring to this region. So what I want to do is I want to change this to, maybe I want instead county by year. Now, if I were to submit this form again, should have another one of these. well, essentially you want to kind of play with it until you can kind of get the positions that you want. I've already kind of done it here. So I said B_1. This one is going to be by month/year. This one is going to be by county. So I'm able to fill in all of these different things. So I have my list of FIPS codes given the state FIPS code. Then I have, I want to only do it for 2010. So I have January 1st, 2010 until December 31st, 2010. And then what we're going to do is all we're doing here is we're saving the unfilled form as the second one. That's the one we're interested in submitting. We want to fill the form. So we want to fill the unfilled one with these information. And then we're going to submit. So when we submit it, we're going to submit our session with our form. That's what I have a period here because I'm using the Magritter pipe. And then my submit button is going to be action send. We can see that here. Submit is going to be action send. So once we do that, I just have it printing the HTML. We get the HTML that we're interested in. So this has the month, day, year code, county, etc. So I have some cleaning code here that I use to clean up the data, but just to kind of show you, here are the headers and here's the general output. So I have Adams County, Allegheny County, Lehigh County, Philadelphia County. This is for PA. And you can see here the headers appear, and then we would just fill that in here, and here's our data set. So this is what we would be crawling, right? We would be doing this, and then we would be saving that data and then trying to scrape it later. So this is a little bit of an involved version. These forms are sometimes you'll find them. Oftentimes it'll be much more like the first two, but just I wanted to kind of have this here so you can come back and look at it in case you do encounter a form like that. The last thing I'll talk about for web crawling is there's this new software or this new language called GraphQL. I think it was developed by Facebook. It's this new querying language for APIs. It's a much more flexible version of an API. I think people have some mixed feelings about it, but if you do come across something like this, I provided some links here that you can kind of check out. So here's an example of GraphQL in R. So this is pretty helpful. They have some code you can look through, but I've only encountered GraphQL like once or twice, so it's fairly new, but maybe worthwhile just to kind of know about. And then that brings us to the end of the crawling section. Now we're going to talk about the more interesting one, I think, in scraping. But before I move on, does anyone have any questions or comments or concerns? Okay. So we're going to revisit this Nix 2019 roster. So I'm just going to pull it up quickly. So here's the HTML that we pulled off from the website and saved locally. It looks like this. And we're going to try to get this table. This table right here has all of the players, their numbers, their positions, things like this. And we're going to try to get this into R. So how do we go from looking at this to looking at it in a data frame in R? So what we're going to do is we're going to read the HTML. We're going to save it as my HTML again. And we're going to try to look for the nodes. So I'm just going to kind of go with me for now. Let's pretend like we all know how to get to the node. And then I'll show you in a second. So we're going to read this data. We're going to use from my HTML. We're going to say, okay, here's the entire HTML document. Please go to HTML node #roster. So the roster node. And then we're going to convert that into a table and we're going to save that. So I'm just going to run step by step. So if we just look at my HTML, it just looks like an HTML document that we saw before. Once we look at HTML nodes #roster, it's going to bring us to this node, which is a table. You can see the ID roster here. And then it's got some information here. And we're going to turn that into a table. Once we run this, you can see, okay, there's one table here, and then you can see here's all the information. So we kind of have already kind of made that jump where we've gone from it's on the HTML page now into R. So we're going to save that as roster. And you can see roster is now right here. It's a list of one, but within this tibble, it's got all these different columns. So we're just going to turn this into a data frame. And now it's going to look like just the normal data frame that you're used to looking at in R. So when we click on this, we have a column for the number, column for the player, position, height, weight, birth date, variable 7. This got the flag has got translated into a lowercase name of it. So like US is going to be the USA flag, experience, and then college. So there are blanks, but they're not NA. I don't know if Zach or Brian talked about missing values, but sometimes there are missing values. Usually these are denoted as NA in R. But in this case, we just have a text string that's literally empty, or maybe it's a space or something like this. But here's how you would scrape just a simple table from the HTML that you've scraped or crawled rather. Now, what's nice about scraping is once you've crawled the data and you've been able to submit those forms or look at those APIs, there's really not too much to it other than pulling it and accessing it and telling the computer where to look for the data you're interested in. So in some ways, crawling is the hardest part, and scraping is actually fairly simple because you're just telling the computer, hey, go grab this node for me and bring it back. So that begs the question, well, how the heck did you know it was called #roster? Well, let's look at it. So here's the page here. I'm just going to right click somewhere towards the top usually. So I'm just going to look at this PG, this stands for point guard, the position that Kadeem Allen plays. So I'm going to right click on this and it's going to have some information here. I'm going to click inspect. And we click inspect. Again, we're going to have elements, which is the HTML for the whole document. So we have head and body. These are the two that originally pop up. And then it actually goes right to where you're looking. So if you scroll up a little bit, Google is nice and it will highlight stuff. Not doing it right now. I don't know why it's not doing it right now, but essentially you can click around and it'll highlight information for you. So for example, once we go to, so I right clicked here, inspected this PG, it brought me to right here. TD stands for table data. What's a little bit backwards in like when you're web scraping versus, or rather in HTML, I should say, versus like R, is in R, you have the data frame or the table and you access columns with a $sign, and then you can access rows from there. In this, for HTML, it's the reverse. You have to access rows first and then columns. So you can't just pull the column of experience. You have to go through each row pulling that experience number. It's a little bit annoying, but that's just the way it is. So TD stands for table data. And we can see that all of these TDs and this TH, which is table header, are underneath this TR, which is table row, right? So we can see this TH is 0, right? It's kind of going down, or rather across that row. And we can see that it's all part of this row. This row is part of this T body, so it's table body. Table body is part of, a similar node to T head, which is table header. Call group is column group, I guess. There's a caption, and then this table. So once you find the table, that's the node that you're interested in. And you can see here it has ID is roster. So we know we can just type in #roster and it'll find that roster page for us. Now, maybe that's too difficult. We can also click on these 3 little buttons here and we can do copy selector. We're using selectors to do this, but you can use XPaths and other things too, but we're just going to stick with selectors for now. So you can do copy selector and go back to your R code, and just to prove it to you, it'll paste #roster. So when you find the node that you're interested in, you can pull that just like that. So that's just another example. Maybe we want this header right here, or we want this guy's name, the trainer's name. If we inspect, we've got another table here, but this one doesn't have an ID. So let's right click on it. Some of this Bachelor reference page is weird sometimes. Sometimes they have these weird placeholders that have tables within. So this actually isn't going to work, but maybe this will. So maybe we wanted to get this header. We want to know what this is, right? If I click on these buttons, copy selector. So we're going to start with the initial HTML document. We're going to go to HTML nodes. And remember, that didn't have an ID, so I had to copy the selector. When I paste it, it's going to go from assistant coaches SH and then header 2. So it's actually going to generate that file path, if you want to think of it that way, for you, which is really nice. So once you do this, you can see, okay, it's an H2, which is just the header. So this is just a text element. And then we can do HTML text. And it'll give us that text that we were looking for, right? Suppose this was some number or something like this, and we wanted that. This is the way we would do it. Are there any questions about this? All right, I'll keep moving. So this is how to extract a single table. So we've gone to one page and pulled one table. If you want to pull from one page 2 items, you can see how I've pulled both the roster page as well as I pulled this other random node that we want. Now, what if we wanted to do multiple pages? Well, what we can do, I have a little for loop written here. Maybe I can start writing it from scratch. So I'll do. So what I'm going to do is I'm going to list the files that are in my working directory. I notice how they're all the Nix rosters that I've scraped. So what I want to do is for each of these files, I want to pull out this roster. So I'm going to say for file in files. I'm going to do pretty much this exact code right here. So instead of read HTML Nix 2019, I want to read the file. And I'm going to save that as my HTML. Then I'm going to go to the roster page, the roster node on each of these pages, save it as roster, save it as the data frame, and then I'll just print the roster for now. So I'm not really doing anything with it other than accessing it. And when we do this, so we've got a whole bunch of different rosters. So you can see where the rosters break because they have this header right here. So each one of these we've gone through and we've pulled the roster. Well, that's great, but now what we want to do is we want to store them somewhere so we can kind of squish them together into one big data frame. So what we're going to do is we're going to have rosters is going to be an empty list. Hopefully Zach went through some of this, but this is just going to be an empty list that we're going to store things in. So every time through this, we're going to say rosters, length of rosters +1. So for example, every time through the loop, I want to look at how many I've already saved and then just go to the next spot. So +1 is going to give us that next indice. So when rosters has a length of 0, meaning there's been nothing saved, they'll save in the first position. Then the 100th time through the loop, it'll save in the 101 position. And we're going to save this as roster. So it's already done. And we're going to smush them together. I'm just going to call this temp. And when we do this, we've got our data set of 190 observations, 9 variables. So you can see how these are all together. The only problem is, for example, if we look up a player on the Knicks. We have Tim Hardaway, number 5, number 5, number 3, number 3. We have his height, we have his weight, we have his experience, which is varying, but we don't really know what year this is from. So a really important trick when you're kind of going through data like this is you need to save where you're getting the data from. And your file name should also be descriptive about what that really is. So I'm just going to save this as file. And I'm going to rerun this code. Why did that not work? Oh. Sorry, I overwrote the whole thing. Now, when we look at temp, we have the 190 observations, but now we know where this is coming from. So for example, if we look up Tim Hardaway again, we can see that his rookie year was in the 2014 season, 2015 season, 2018, 2019. So this is how we would grab data from a bunch of different files. So we've crawled these 10 roster pages and we pulled the roster page from each one of these, and then we've squished them together, and we found that Tim Hardaway was on the team for 4 of those 10 years. So here are 2 ways to do it. I think these are probably very similar to what I did before, but you guys can feel free to look at it. Now, what if there are non-tables? So for example, what if we don't care that Kadeem Allen or Tim Hardaway Jr. were on the Knicks at that time, but rather we want to know their statistics, right? So this doesn't say anything about how many points Tim Hardaway scored. It doesn't say anything about, I guess it does down here, but maybe we want to go to his page and we want to get some other information about, I'm going to use Kadeem Allen because he's the top player. So what we want to do is we want to take this and we want to follow this link. So if I went to Basketball Reference, find the Knicks roster from 2019. So if I click on Kadeem Allen here, it's going to take me to Kadeem Allen's page. So you can see the years he played, the points he scored, other information like the jersey numbers he wore, all sorts of information. Now, if I do the same thing on the local version, the one that's on my desktop, if I click on this, it's going to break because it's trying to access, the way it's set up is for it to access the one that's online, but I'm not really on the Basketball Reference page, so it's not going to work. So what we want to do is we want to figure out how do we get those links from here such that it works like it would on Basketball Reference. So what we're going to do is we're going to, again, pull the same exact page into our HTML. So you have the New York Knicks roster. We're going to read that as my HTML. Again, we want to go to this table again. So what we're going to do is we're going to access the HTML node that's roster. So let's do this way. So when we did it the way we did it before, we're just going to get Kadeem Allen, but we don't get Kadeem Allen's like his hyperlink, his URL that comes with it. And if we want that, we're going to have to access a little bit differently. Oops. So we're going to stop short of HTML table, and we're just going to look at the node. So we have the table here, but let's actually look at what this is and let's try to figure out how to access this. So if let's click inspect on his name, and we see within the TD, there's this A tag. A tags are usually for hyperlinks or just a little piece of text or something like this. So what we're going to do is we're going to try to grab this A tag, because this A tag has Kadeem Allen's name, but it's also hyperlinked to his player page. So what we want to do is we want to take this roster node and we want to drill down and say, okay, give me all of the A tags. Right? The A tags are the ones that have the hyperlinks. So we run this, we can see, okay, we have A, href, players /A, Allen, KA, Kadeem Allen. So this is Kadeem Allen's URL, his player page. Then we also have this other one, which is Friv Colleges, FCGI. And if we look back here, it's just hyperlinking that he went to Arizona. And then you can go to Arizona's page and see other NBA players that went to Arizona or something like this. So we don't actually want these ones. We only want the ones with players. So we're going to save this as links. And hopefully Zach did something like this with you guys, where you're able to show, okay, we need to do some logic to subset this vector. So we're going to say we only want the links where we can find players. See, we only want the ones where we see players in the link. So players, comma link. And remember, this is going to give us a true or false value. So here are all the true, false, so true, false, true, false. And if we save this, and we reprint links, we now have all of the A tags that have links in them, right? But now instead of just stopping at the A tag, we want this attribute right here, right? So what we want to do is we want to ask for the attribute href. Href is equal to this, which is the actual thing that we want. So now we have all of those hrefs or those links, and we're going to do the same exact thing. So we're going to save these links. We're going to subset the ones where you can find players, like the actual text players, and then we're just going to print the links here. So we have 22. We have 23 of these hyperlinks to each of these player pages. And our data set is 23 observations long. Every player gets a link. So now we're going to do roster link, and we're going to do paste 0, because notice how basketballreference.com is not in this hyperlink. So I'm going to take this right here. So copy this, put it in this paste 0, and then links. Okay, so now if we look at our head of roster, we have all of these links. We have Kadeem Allen, all of his information, and we have how to get his hyperlink to go to his page, right? So now what we can do is we can go say, okay, now we have his hyperlink. Now we can go visit his page, because now we have a whole new list of links to scrape from or to crawl. Are there any questions at this point? Okay. So this is how you would get something that's on the table that's not in the text. So this is like something that's inside the table, but through a hyperlink. So now we have this table, and we have an extra column here that has the hyperlink that these are referring to. We could do the same thing for college, right? And we can augment it here. We just have to be careful about some of these players not having gone to college. So for example, this guy, Enos Freedom, that's he changed his last name. His last name is not actually Freedom, or was not Freedom rather. And he maybe went to college, but he's a foreign player, so they don't count it. You can see here he's from a different country. So that's how you would grab that information. But now let's see on Kadeem Allen's webpage, on his page here, we can get his Twitter account, right? So we can kind of keep going down this path. So we can get the Knicks roster, we can get all of the hyperlinks for their player page, we can crawl all their player pages, and then we can get other information from there and keep connecting these data sets. So with unique identifiers and things like this, we can kind of keep going through this. So for example, if we wanted to know what all these players were tweeting about and see how if tweets correlated with performance or something like this, we could do it. So we can get Kadeem Allen's Twitter page by going through some of this here. So I'll walk through this rather quickly. So once we have our roster page, we've got our link. So our links are not like that. So we have to do nix. I don't think we saved it. Oh, I think it's roster link. So for each of these links, I'm going to just do the first 4. So I'll just say I is equal to 1. So this first link is going to be Kadeem Allen's page. We're going to read the HTML. And then at this point, once we read the HTML, usually I would save the HTML, and that would be the crawling step. And then afterwards, you would scrape it. But because I'm only doing 4, it's rather easy. Not going to worry about doing saving that HTML and then coming back to it later. I'm just going to do it all in one step. So I'm going to find some node, which is called meta. Let me find it here. So again, if I wanted to find why am I picking this node meta? Well, I can click on Kadeem Allen's page. We want his Twitter account. So this is his page. We want this Twitter account. So we are going to click on it, right click, inspect. We got it right here. So we're going to go up a little bit. We see strong, we see P, we see a div, and right here we see ID meta. So that's how I'm getting meta. That's giving us this whole section right here. So I copied hashtag meta, put that here. And then from meta, I want all of the A tags. The A tags are going to have that href or that the hyperlink. Click on this, we get 11. We have this twitter.com. This is just a hyperlink to Twitter. This is hyperlink to his Twitter account, his Instagram, I guess, his birthday, birth year, birthplace, all sorts of other information that we don't really care about if all we want is his Twitter information. So from here, again, I'm going to grab all of all the ones that have an href to it. And here we go. I'm going to save this as temp. The temp is just going to be all of these links. And I have to figure out, what does this link, the one that I actually care about, have that's unique from all the other ones? So it actually just has twitter.com, which is unique. So I can say, okay, which ones of these can I find this text string in it? It says false, true, and then a bunch of falses. So this is the only one that has it. When I do this, I have temp. Now, if a player doesn't have a Twitter account, this will just kind of delete everything, right? It won't actually have a hyperlink. It'll just kind of say nothing. So we have to make sure that temp is not empty, right? We have to make sure that there's something in that variable. So what I'm doing here is I'm saying if the length of temp is greater than 0, which is true in this case, then we can assign Nick's Twitter the ith one, which is the first one here. We can assign that to temp. So if we run this, now let's look up our roster. Oops, supposed to be roster. If we look at roster, now we have an extra variable where the first 4, because I've only did 1 through 4, is going to have the people's Twitter account. So we have Kadeem Allen, we have Ron Baker, Trey Burke, and Damian Dotson. And then, of course, from here, then you can go onto the Twitter account and get other information, you know, and so on. So this is kind of how you would put together a web scraper that's going to aggregate multiple different data sources and kind of make one file that's going to be unique, because this is not necessarily downloadable. Player and their Twitter handle. Are there any questions? Comments, concerns, anything? Okay, so I got a thumbs up here, so I'm gonna keep going. Something else that you might want to do is something called error handling. So if maybe you have a bunch of hyperlinks, but you can't really manually check them all, and you're not sure if all of them are going to work. Or for example, let's suppose you were scraping the roster pages from 2010 to 2019, but maybe there was like a lockout year or the NBA didn't play or it got shut down because of COVID, and you're not really sure that all of those links are going to work, and you don't want your code to break, but you still want it to, if it does break, you want it, you know why it's going to break, because for example, maybe there was no 2020 season and we're going to scrape 2010 to 2020, and you want to kind of prep for this. You can do this with error handling. So this is a little bit outside the scope of web scraping, but it's used often with web scraping because sometimes you might have a website that you're trying to scrape that has a timeout. So after 30 minutes of use, it'll kind of block you, and you have to like reset your scraper. I had to do this just recently with something I was scraping, like literally this week. So error handling is very important, and something that I think would be really cool if you kind of were exposed to. So the way to do this would be, okay, let's say we have, fat fingers like I do, and we want to scrape the Knicks roster in 3019. So if we type this in, it's going to give us a 404 error, right? So this is not going to work. But rather what we can do is we can say, with this try catch function, we're going to say, do this and return that to me. However, if there's an error, this is what I want you to do. I want you to print there's a 404 error. You can create a custom error and then just keep moving on, right? It's going to break here. This is not going to work, but it's not going to stop your code. It's going to still execute what happened in the event of an error, and it's going to be able to kind of keep running. So let's see what happens when I do this. So here's something where I'm planning for an error, right? I know this is going to give me an error. Maybe I don't know ahead of time, but I know that this will give us an error. And this just says 404 error, try again. But let's say I say, okay, well, that was a mistake. I meant to do 2019, and we can run this line of code. And now it's going to run completely normal. It's just going to execute this part because there is no error. So when we run this, it's going to give us that head, body, that HTML that we're used to seeing. So then you can kind of go through each of these links that maybe you're unsure if they're going to work or not. Maybe you're not sure if the website has changed or something like this. You could do these try catch things that are really helpful. Another thing that I want to just kind of touch upon are our Selenium. What our Selenium does is it kind of takes the API and the form stuff to a whole new level. It essentially, you're really driving the browser. Like it will literally open the browser window on your computer, and it'll scroll, it'll click, it'll type, it'll do whatever you program it to do in real time. So if you are having some trouble with scraping some website, this is like a last ditch resort. It will for sure work, but it's really cumbersome and difficult to program, just because of the kind of the functionality in which it is, where it actually simulates the true user experience. It's much slower, stuff like this. So if you really need to use it, it's a tool available for you, but I would recommend against it. I would say almost always there's a way around it. You don't necessarily need that. And the package a year or two ago actually had a different maintainer, so they've just switched over, and this person seems to be not updating it as often. So I'm not sure what the future of our Selenium is going to hold, but it's there if you need it. So the next thing is, people ask me often about scraping data from PDF. It's a nightmare. If the data is really, really, really formatted, I can give you an example. Here's like an example of a very, very formatted PDF. But essentially what it does is it treats it like a text file. So it will strip the text and everything else from the PDF into like one giant text blob. And then from there, you have to, hopefully you guys went through some tech stuff with Zach and you're able to kind of parse through it and get the data that you want out of it. But it's really a headache. So I would really advise against PDF in like every way. Sometimes there's no other choice and you have to do it. There's some optical recognition software or something like this where it will read like scans into text and then you can use that. But again, not very reliable. PDFs are like just the worst way to store data. Like it's great for papers and PowerPoints, but data is just like the worst.
Alex,
Yes.
so like if I've used Acrobat Pro to take a PDF and convert it into a CSV or an Excel file, so
Yep.
that might be an option. You know, once you convert it, you might be able to take it from that.
Yeah, that's true. So a lot of universities have access to Adobe or something like this where you're able to load up the file and kind of convert it. But even then, I've tried that a few times, and even then, I've had some difficulty. So it's I mean, if that works for you, then great. For me, I like everything to be programmed so it's replicatable, and I don't have to point and click at all. Because once you start to like point and click stuff, then it's like hard for me to remember sometimes how to get from point A to point B, or it's not just like completely automated. So that's a great point, is that sometimes PDFs can be converted, but I still think it's tough, I think.
Gotcha.
The last thing I'll touch on is parallel programming, but first I want to just stop and ask if anybody has any other questions.
Is PDF uncoding, like switching the format of that, terrible in any coding language, or is it just like particularly rough in R?
It's terrible all the time. I don't know if R is better or worse. I've tried doing some stuff in Python with it. Haven't really enjoyed that either. It just seems like it's really difficult because PDF is almost like a picture. So to parse that is difficult. So I just like recommend against, if you can find any other way to get data that's not in a PDF format, do that. But there are ways to do it. If you have a bunch of PDF data and you want to talk about this, we can do this after the session. I'm happy to, but generally stay away from PDF in terms of storing data. Are there any other questions about PDFs or scraping? Okay, the last thing I'm going to teach is called parallel programming. And I want to be clear about this. I'm not the strongest with parallel programming, but it is a really, really handy tool. So I'll teach you guys what I know. I'm using Windows and I have a PC. So I think Macs and PCs do parallel programming differently. So if you have a Mac, you might have to look into it a little bit more than what I'm going to show you. And also, if you are using a different operating system, it might also be an issue as well. I'm not sure which one is better or worse or whatever, but this is the way it works for me on my machine. But I'll just want to preface that. But essentially what parallel programming is doing is R is a single worker. It's like one person. So it can only scrape one website at a time. So it can visit the one link, scrape that data or crawl that data, store it, go to the next one, store it, go to the next one, store it. And it's very sequential. Parallel programming works when, let's say you have 100 links to visit and you don't want to have one person go through all of the links and you have like a research team, you can split it up over 5 people and each person gets 20. So parallel programming is going to work just like teamwork, where the computer says, okay, I have some amount of cores. My computer, my personal machine has 8 cores. So what I'm going to do is I could run, I think more than 8, but I think realistically the maximum is like 7 or 8 instances of R at the same time. And I'd kind of divide up the links appropriately. Now, I don't have to tell the computer how to divide it up, or I can be a little bit more explicit and kind of force its hand a little bit. So I'm just going to kind of walk through this code right here, but we're going to load 2 packages for each and do parallel. And the first thing we have to do is figure out how many cores we can work with. So again, my computer has 8 cores, which is like 8 CPUs. And I'm just going to use, I don't want to use all of them because I'm either on Zoom or on the internet, and I just don't want to like overwhelm my computer. So I always use like 3/4 of the available cores. So I'm going to detect the number of cores on my computer is going to be 8 times server 4 is going to be 6. So I'm going to print the number of cores. I don't think I have output here, but it's going to be 6 rather. I have the same number of years that I'm going to scrape, so 10 years. But now, instead of having just the NICs, I now have 6 different teams. So I'm going to register my cores, so these 6 cores that I've specified. I'm going to register them as part of this R process. And instead of a for loop, we're going to do something called for each. So for each team and team, right? So for each one of these, I'm going to supply the packages, so rvest and magritter. I'm going to, I think I should do XML too because I'm using this right HTML function. But we're going to do this in parallel. So what this is going to tell the computer is saying, okay, I have 6 teams and I have 6 cores. This is obviously very staged. But if I just want to do all 30 teams in the NBA, I could do that as well, and it will figure out how to divvy it up. I'm not even sure if it's going to divvy it up 1 team per core. I have no idea, but it's going to figure out a way to split up this process. So what's going to happen is each core is going to get this chunk of code to run on its own. So the first core is going to run New York Knicks, right? So this TM, and then it's going to run this year through this for loop. And it's going to do this the same time as it does DAL, which is Dallas, alongside the Lakers, the Clippers, the Boston Celtics, and the Chicago Bulls. So it's going to do 6 of these processes simultaneously in parallel, instead of doing all of New York, waiting for New York to finish, then do all of Dallas like a regular for loop. If you nested these 2 for loops, you would do all of New York, all of Dallas, all of Chicago, right? It would kind of go in order, in sequential order. In this case, it's going to spread out, it's going to distribute the calculation or the routine. So this works because it doesn't depend, like me scraping 2010 Dallas does not depend on if I've done New York yet, but that's because they're completely independent. Now, if the processes you're doing are not independent and they are dependent on one another. So for example, you have to do New York 2010 before you do New York 2011 for whatever reason, like in web scraping, it doesn't matter. But in like, running regressions or something like this, you would not be able to use parallel programming because they have to be able to happen simultaneously. Now you can run multiple regressions in parallel, of course, but this would just be a way to really, really speed up your calculation. This will divide the time it takes by a little bit less than 6. There's still a little bit of overhead. Once it does all of the routine, it has to kind of combine them at the end. So there's a little bit of a slowdown at the very end. But generally, this code will be way faster than doing it in like a nested for loop where I do all of New York, then all of Dallas, and so on. So parallel programming is super, super powerful, and I think not really taught very often, but this is a really cool tool I think graduate students should be exposed to. Are there any questions about parallel programming? I would encourage you guys to try it out by yourself, especially if you have a PC and you're using Windows. Then this should work, and you can time it on your watch or something like that. You can run this code, and then you can run another for loop with this. So for example, if you wanted to write sequential code, so this would be the parallel code. If you wanted to write it in like a sequential version, you would do for team in teams like this. So this is going to for each team, you're going to do the for loop, and it's going to be in sequential order, or this one's going to be in parallel. Any questions? Okay, I'm gonna stop recording because this is all I have planned except for this homework. We did go a bit quick, so I think what I'll do is I'll go over the homework with, not that it's like homework of any sort, just like ways to practice maybe. Maybe I'll kind of go through the homework with you guys, but if you want to take a break, feel free to exit the Zoom or just kind of walk away from your computer, go get water or something like that. But I'll work through the homework with you guys if that's desired. But I'll stop the recording here.